Okay, so today we're going to do another session, and this time it's going to be about relays. Okay, so on this particular video, on this live, we're going to be talking about how a relay works and how to test a relay. For the purpose of this video, we have opened up this simulator that you can use. This is free of charge. All you gotta do is just open up an account, and let me just verify. Let me make sure that we have good audio on this thing. And very quick. And let me just verify. So it seems to be that we do have good audio. So, okay, let's continue with this thing right here. Premium controls. Okay. So remember that we're just gonna wait a little bit, see if we can get someone to join us on this session. And so for anyone that is gonna be watching this at a later time, let's talk about a little bit about this simulator. Okay, we're gonna start simulator. This one, I mean, I don't know of anything that looks like this. If anything else, if anything else is available out there, but this made by this company, Elected, is it's very helpful. So we're going to talk about some of the instruments that they have. We have the instrument panel. We have the multimeter. I usually don't use the multimeter. I'm gonna pull out my oscilloscope, and besides that, I'm gonna get my diagnostic system, my breakout box because it's always handy, and my wiring diagram. Okay, remember when we're doing electrical testing, we need an electrical diagram. Okay, so let's start this engine. Okay, as you can see, this is fully functional. And first thing we're gonna do, like we do on any other car, we're gonna identify the vehicle with using our scanner. And as you can see, it read a VIN, so that means that the scanner is capable of establishing communication with a module. I don't know which module it is on most of the vehicles. The VIN that is read by the scanner is from the PCM or the ECM or the ECU, which is the main computer for the engine. When I'm talking about a PCM, I'm referring to a powertrain control module that has an engine and transmission control built into the same unit. So that's a powertrain control module, also known as PCM. We're going to read fault codes. There is no fault codes here. But something really good about this simulator is that it's very effective. We're going to disconnect the component. We're gonna go back over here and read codes again. As you can see, it gives us a code for the injector circuit and also for the misfire. So the fact that we disconnected this injector, that's causing a misfire and triggering two different codes. One of them is for the injector circuit itself, and the other one for the misfire that that is being caused by the injector not being connected. We're gonna connect this back in there. Today I wanted to talk about relays. Okay, I'm showing up I'm showing this simulator because this is something that I'm going to be using whenever I try to give a more graphic presentation of whatever we're talking. We have relays here. We don't have we only have three. Let me turn the volume down this thing a little bit. And hopefully it's good. It's still good. So relays. as we can see, we have our K1, K2, and K3. Okay, and these three relays we can find on our wiring diagram. First, I'm going to show you this wiring diagram, and then I'm going to show you another color wiring diagram from all data, which is this right here. Okay, and yesterday we were talking about uh, pressure sensors. Okay, I was telling you about pressure sensors, 5 volt reference, load reference, and signal. That was yesterday. Today we're gonna be talking about relays. Okay, on this same diagram, we're gonna look for relay, and what better than our fuel pump relay? So what we're gonna do with this? Um, we're gonna talk about depends on relay. So most universal relays have at least four. Well, they have some. Some of them have like 3 pins. Some of them have four. Some of them have five. Whatever we're gonna find, the thing that we're gonna find most of the time, it's gonna be a 4 pin relay. Two of them are gonna be for the control. The other two are gonna be for the load. Okay. So how does a relay work? Well, a relay is just a switch, okay? Whenever we command a relay to turn on, basically what we're doing is we just closing the switch, okay? This is the switch right here, and this is the control over here. So how do we control a relay? That's very easy. I mean, on the control pins, which you have good ground on one and good battery voltage on the other one, and that would generate a magnetic field on the coil, and that magnetic field is going to pull on the switch, and that's going to close the switch. So when it does that, whatever we have on this pin, we're going to transfer into the other pin. Okay, so when we get universal relays, we get these numbers on it, and usually you're going to see 85, 86, 30, 87, and 87A. 87A is an alpha. So 85 and 86 usually are for the control. Okay, you can wire them either way. You can wire ground on 86 and power on 85. It'll work. The correct way to do it, especially because some of them have some other additional components in here, like you can see here, this looks like a resistor. Some of them have diodes. So the proper way to connect the relay is going to be ground on 85 and power on 86. Okay, so if we have ground and power, that's going to energize the relay, pull on the contact, and close the circuit. That's how a relay works. Okay, so for the control side, it's going to be that 85 and 86. For the load side, the load or the switch, usually we get 30 on the input and 87 on the output. Some relays, universal relays, they have another pin that is called it's labeled 87A as an alpha. So that is usually a pin that is normally closed. What am I referring to? You see that right here? Imagine this being connected to 87A. So what's going to happen when you energize the relay? When you put ground and power, you're going to pull on this lever, and it's going to close this switch, but it's going to open up this one over here. So a universal relay, it's a device that you can use to either close a switch or to open a switch. Okay, and that's a function that you see a lot on power windows. Let me pull out another diagram for some power windows. See if we can show you what I'm talking about, because this chat today was going to be specifically for that used relays. This is a truck that we are working with, and let me see. Let me go onto power windows. Where are they? Power locks. Windows. Let's see right here. Windows. Power windows. Okay. So on my power window diagram, what do we have? Yes, no. No, this is not going to be a good one. Let me change to a different vehicle. Let's go on this Nissan. It's the vehicle that we're working with today. This had a bad computer, bad control output for a relay, actually, for the main relay. Let me see. Let's look for Windows, power windows. Uh, Let me see. No, no relays here. These actually work with just buttons. Man, let me just try another one. If not, we're just gonna talk about them in a different video. Let me see what car has relays on the power windows. Let's just pick one of the ones that we've been working with. Let's see this 2013. Okay, let's see. Windows were at the bottom. Windows, power windows except hybrid. Mm, well, this doesn't have relays, but this is exactly what I was talking about. It's not a relay, but it works the same. As I was telling you, 87 is connected on 87. It's open and it closes when you energize the relay, and 87A will be closed and then it'll open up when you energize the relay. Okay, so this one closes and this one opens. So if we look at it, imagine this being the actual relay. Okay, I couldn't find a diagram that had the actual relay, but imagine this the way it is right now. Usually when you have them in this setup, what you have is that all of them are connected to ground. Okay, and then you have these two sides of the circuit. So both of them are connected to ground. Let me see right here. If we close this switch, this splice is going to be connected to ground. So that's going to be our path to ground. This whole thing is going to have a ground, right? So everything has a ground. When you turn the relay on, this one will switch this way, and it'll be opening up with the ground and connecting to the power. Power comes from, pretty sure it comes from fuse right here, fuse. Okay, so at that point the window will operate in one direction, and when you open up the other switch, now you'll be doing the opposite. Both of them are connected to ground. You switch this one over to power, and at that point we have power and ground. And when you let go, both of them go to ground. And when you do this on this end, it'll be the other way, power and ground. Okay, so these connectors, or these contactors right there, are going to be the ones that are inside the relay. Okay, so a little bit of imagination and you'll be able to figure that out. So that's the way we have a relay set up. So how do we test a relay? Okay, how do we test a relay? So it depends on what you're trying to achieve. It depends on what the relay does or it doesn't do. Number one, we have to know that every time it's not commanded, it should be open. Okay, because sometimes we get relays that stay stuck on the on position, which is a problem on some vehicles, on most vehicles, I want to say, on most systems. I mean, these are intended to be operated when when it's commanded on, not all the time. Okay, so how do we test the relay? So remember, when you want this relay to be operational and closing this circuit, that means that you're going to be feeding power and ground. So since you don't want to be switching two circuits, uh, the way you do it, you pre-wire one of them and then you control the other one. It doesn't matter which one it is. You could wire this one to power and then control the ground, or you could wire the ground to a chassis ground and then control the power. You could do that. So in this case, what do we have? As you can see, this symbol is for the ground. So this wire is grounded all the time. That means my control is on this wire. If we follow it, this is gonna go to the computer. We follow it this way, and this is my computer powertrain control module. And the reason why you want the computer to control the fuel pump is for safety purposes. Okay, the computer will not energize this fuel pump other than the prime, or other than the prime when you turn the ignition on. It will not energize this circuit unless there is CKP signal. Okay, so some vehicles will run the pump or prime the pump when you open up the door. Some of them don't do until you turn the ignition on. Some of them do it when you put the key on the ignition. Different scenarios, right? But at the end of the day, most vehicles will prime the system and then it'll stop and then it'll run again once you have a good CKP signal, okay, or CMP for the camshaft or crankshaft. Some vehicles, especially newer vehicles, are able to start and run with a missing signal. It could be that you're missing your cam A, your cam B, or your CKP, and it'll still work. The camshafts have enough information for position of the CKP. Although you cannot, even if you cannot see the signal, it knows where the position is, and it'll fire up the pump. But anyway, so testing on a relay. When you go into this relay, it's important to know that most of the times you're not going to have access to it. It's not going to look like this, where you can see the wire. Most of the times, a relay is sitting over here, and you cannot access the pins. The pins are underneath. They sell some. They sell some relay adapters. Let me see if I can find something online. Yeah, this right here. These are good. These are the ones I have. I have a set of this, but let me see if I can show you a close up on one of them, so I can tell you the way we use them. And let's see. I'm gonna have to show you on the one that was out here. Nothing there. Nothing here. Okay. Now let's just open this up. Um, Not even a good close-up picture. Okay. All right. Well, just for you to know, these pins over here, down here, you actually remove the relay and you install the adapter, and then you push the relay in on top, and then it's got pins out here, and these pins are connected to these pins, so these are exposed once you install the adapter. Okay, so that's something that you can use. These are expensive. I mean, I don't know why they're not a little bit more affordable, but here are the pins, as you can see them. These pins are the ones that are actually right here. These pins are the ones that go instead of the relay, and you cannot actually see them, but over here there that's where the other pins are that are connected to these ones. So once you put this in place, you remove the relay, you put this thing in place, and now you can test on this end, and this end is also labeled. So let's see, let's go back to our diagram. And remember, when you are commanding this relay, you want to have good ground, good power. Now let's talk about the switch. Okay, on the input, which is always going to be, well, most of the time it's going to be on 87 on a universal relay. On the input, you're going to have power. You you can wire to have power. You can wire to have ground, depending on the circuit that you're going to be controlling. You can control a ground, or you can control a hot circuit. Okay, so in this case, and which is the case for most relays, for most automotive applications, this is going to be your input. Okay, and it's gonna have power. Okay, now once you get ground and power here, this should close, and we should also have power on this other wire. So let's talk about a couple of scenarios. Okay, when this is not control on, when this is not being commanded on, what should we read here if we're measuring with a let's say a power probe or a multimeter? If we read it with the power probe, what are we going to read on this pin with the relay turned off? We're going to read ground. Okay, where does that ground come from? Well, that ground comes from here. Let's follow the path. It goes out this way. Okay, into the motor, through the winding, through the winding on the motor, out of the motor, back into your ground. Okay, so whenever we are reading um, this wire and the relay is off, you should be reading a ground here. Okay, so when you turn it on, what happens to the ground that you were reading here? You will no longer be reading a ground, you'll be reading a power. Why? Because you're reading the power that is coming this way. Does it short out because you had a ground and now you have power? No. Why? Because the voltage drops across the motor. Okay, so at that point, when you energize this relay and you turn it on, and this thing is feeding power here, the power will come all the way to the motor. And at that point, we're going to have good power here, good ground here, and this motor is going to run. Okay, so it's important to know when the relay is commanded on. If you have something that is commanding the relay on and you have power here, ground here, power here, but no power coming out, you most likely you most likely dealing with the bad relay. Okay, if you have ground, power, nothing comes out here, right? Nothing. You connect it here. You cannot read ground. You cannot read power. Nothing. And when you turn it on, you can see power. That means that probably your component is disconnected. Okay, that could be the case. It could be that your component is disconnected. Now let's talk about another scenario. You energize a relay, ground, power, but you have a blown fuse. Even if this closes, even if the relay is good and the circuitry is good, if you don't have a good fuse, this thing, even if it closes, is not going to feed anything into the pump. Okay, so that's gonna be the explanation on this wiring diagram. We're gonna move to the simulator. Okay, on this simulator we have a couple of relays, and we're gonna be working with this one right here, the one for the cooling fan. The cooling fan. Let's turn the engine off. Leave the ignition on. We're gonna, let me see. We're gonna turn on my oscilloscope like that, and then we're gonna go measure. We're gonna do a couple of measurements on these relays. Okay, so we're gonna use the relay, which is this one right here, K1. Okay, K1 is gonna be the relay for my cooling fan. So since we don't want to wait for this cooling fan to come on its own, we're gonna go with our simulator and command it. Let's see, systems engine management, actuator test, ECM, and right here we got our fan relay. Hopefully you can see that, you can hear that. My relay runs and my fan runs. We're gonna turn it off for now. Okay, so we're gonna try to zoom in a little bit here. So on K1 we have 4 wires, okay, just like we were talking about on the other one. And let's look at the diagram. These 4 wires are gonna be these 4 right here, okay. This line is connected to power. Since this is connected to power, it's connected to this wire right here, so it's going to be hot all the time. So pin number 1 is going to have power all the time. Pin number 4 is connected to the ECM, and the ECM is the one that we are commanding, the one that we are controlling here, okay. So for this ECM to energize the relay, it's going to need to see some input, something that is requesting this temperature to turn the cooling fan on or off, or we can command it from here. So on this one, let's see, wire pin number 4, which is the brown wire, is this one right here. When we're gonna be measuring, we wanna try to, once we know what we're looking for, we're expecting to see something. We're expecting to see voltage on both wires, this wire and this wire. Okay, both of them. My scale is out of whack right here. So that's 1 volt right there. So that's 5 volts per division. That's gonna be 5, 10. We expect to see voltage at around this line right here, a little bit above this line. We want to see voltage on both of them. Why? Because on this one, as you can see, we have a battery voltage, right? That's the voltage that we are supplying here, okay? And on this one, we also want to read voltage because the relay is not commanded on, okay? So this wire goes to the PCM or ECM, but inside it's not connected to anything. It's not connected to anything, so whatever we have going in, we should have going out. Now, when we command the ECM to turn it on, the ECM is going to ground this wire. At that point, we want to see this drop, okay? And for that, we're going to command it. We're going to turn it on. We're going to turn it on right there, okay? As you can see, it dropped. And hopefully you can hear my cooling fan running. Okay, hopefully you can see my cooling fan running. That's because the ECM is grounding this wire, pin number 2. It's grounding pin number 2. If we turn it off, it goes away. On, off. Okay, so that's going to be for the control, this area right here. So what should we see on the other ones? On pin number 2, which is the one that comes from this wire, which goes through fuse 15, we want to see power there all the time, because that's a battery feed, okay? So that's fuse 15. This fuse right here is the one feeding this wire. So we're gonna check it. Like that. And as you can see, it's high, okay? And just to make sure that we have the right wire, we're gonna pull fuse 15 and this should drop. Right here. Okay, as you can see, it dropped. We're gonna put it back in place. We're gonna take it away again. Put it back in there. Okay, so we have the right, this is the right wire. This wire is this wire over here because we're pulling fuse 15 and we are losing the power here. So this should have power all the time, okay? Now the other one, what do we want to see on the other pin? We want to see a good ground when the relay is turned off, okay? And that's what we have. Now, what do we want to see when we turn the relay on? We want to see good power. Where does that power come from? It comes from the other wire right here through the contactor inside the relay. So I'm gonna turn my fan relay on and see what happens. As you can see on my oscilloscope, it went high. We're gonna turn it off and it dropped again. And we're gonna turn it back on. Okay, hopefully you get the idea, because this is what it takes to diagnose and troubleshoot a relay. Okay, so now if you have any questions about relays, I mean, if you have any questions about electrical diagnosis, you can ask questions on the chat. I'm gonna try to answer them. Um, as we go, as we move forward in these tutorials, or I don't know, these video chats, um, I'm gonna be talking about different topics, different things. Yesterday we talked about pressure sensors and position sensors. Today we're talking about relays. Tomorrow we probably going to be talking about computers and communication, what to test on a computer. I don't know that you need to replace a computer. Uh, what's involved into testing a computer? Good grounds, good battery voltage, good ignition, good communication network, no shorts on the outputs, especially for 5-volt reference. That's what we're gonna be talking on the next time that I launch another broadcast. Um, so in the meantime, if you have any questions, make sure you can put them on the chat. If you don't get to watch the chat on the live version, you can still add the comments, and then once we review them, I'm gonna try to do them. I'm gonna be trying to do this um, at around 8 p.m. Pacific time. I don't know if I can do these on a daily basis. Okay, I'm gonna do my best to designate at least like half an hour to talk about a topic. And if you have a question about electrical diagnosis, you can ask me. I mean, I know a little bit electrical. I know a little bit about programming. We do a lot of programming at the shop. We do ADIS calibrations. We do a lot of troubleshooting on electrical systems, and you can visit us on the channel at ADAS Calibration Service. And if you want to participate in the future, make sure that you see us back here probably tomorrow. Okay, tomorrow I'm gonna try to be here tomorrow around 8 p.m. Pacific time. In the meantime, thanks for watching, and remember that if you want to try this simulator, you can find it on simulator.electric.com/simulator. It's free. All you gotta do is sign up. You know what? Before I go, this you can actually play with it. And before we go, let's see what they have for us today. Okay, usually they give you like an assignment, like the engine does not run. Okay, let's try to apply some of the knowledge that we have and see if we can make this engine run. Okay, so as always, let's pull our instrument panel, not the multimeter, oscilloscope, diagnosis system, breakout box, and wiring diagram. Let's see. Okay, we're gonna start the engine. Oh, now that I remember, the engine doesn't start, right? That's the problem. The engine doesn't start. So, number one, let's identify the vehicle. Let's see if this thing communicates. Okay, if we have a VIN. Now, does that VIN come from the ECM? We don't know. Let's go and try to go into different systems. Engine management, fault codes, ECM communication not possible. Okay, so unable to communicate with. Okay, give me a second. No, 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 no. This is not a. My bad. We can communicate. We can communicate with the ECM. That's where we getting the That's where we getting the code from. So engine management, fault codes. communication not possible. So the ECM cannot communicate with something. Okay, and let's see what we have on this engine that could be preventing this from running. We don't have many modules in here. Okay, as you can see, this one does not communicate, and that's going to be our throttle body. Okay, and it doesn't have many modules. It's got the ECM and the throttle body, but it has a good designation for communication, and we don't need more than this. I mean, any other module outside these two, it'll be just an additional module for this system. So since we don't have communication with throttle body, let's try to troubleshoot for that, and let's pull our wiring diagram. For that, we're gonna see what we need on our throttle body. Good we have a CAN bus, we have a power feed. Okay, remember this is a relay, that's my fuse, this line should be feeding power here. Okay, so we have good power, we have good ground. Okay, we should have good ground, and we should have a way to communicate with the ECM through CAN high, which is this, and CAN low, which is this right here. This I imagine is gonna be for my TPS, if I'm not mistaken. We can look it up in a minute, but for now, let's just do some basic troubleshooting. Let's see, let's talk about these wires right here. So we should have good power on 1 and good ground on 5. Okay, let's hook up my, let's put this aside. Let's hook up my multimeter and then turn it on. We want to see more of it. I mean, like that, 5 volts, okay? So from here, let's see. On pin number 1, we want to see a good power, which we don't have, okay? On this one, we want to see good ground, okay? On this green wire, we want to see my can low. Can low is going to be from 2.5 down to 1.5, okay? And what do we see? What do we have in there? What am I doing here? Okay, so we got, no, we want 2 volts per division, okay? And okay, that's my canvas. And if we have 2 volts per division, we have two, a little bit over 2.5, something around 2.5, as you can see here. So this, it seems to be okay. Now pin number 3, which is green with the white tracer, that's going to be my can high. Can high is going to be from 2.5 up to 3.5. So this one's 2.5 down to 1.5. The other one should be pretty much just like a mirror. Let me see if I can turn on my other channel. Um, Good, good. That way we can see both of them together. And um, timing. Let me drop this a little bit like that. Okay, as you can see, mhm, as you can see, my blue one, it's mirroring my red one. Okay, and that's what you want to see on a kind of high and a can low. So let's see. What else? What other tests can we do to determine if we have an issue here or not? Let's do something very quick. Let's go. to another component that uses the same power as this feed right here, which is going to be my injectors. So we're going to go to an injector and we're going to see if we have power at the injectors. Let me see, we have an injector here. This is an injector. Let me zoom out so you can see what I'm talking about. Injectors and coils. So using my red, okay, we know that the communication network is good. We're not going to be using this anymore. On my oscilloscope, I'm going to grab this and I'm going to go check. Okay, I'm going to go check the power on one of the injectors. What do we have? No power, right? Ignition off, ignition on, no power. What should we have here? Power. Where does that power come from? That power comes from here. This is injector number, what is this, 401? Looks like this is injector 4. This looks like we have a transmission here. So the front of my engine is going to be here. So this is going to be probably injector 4. Okay. So regardless of the position, okay, but I'm pretty sure it's 4. Um, these should be hot coming from fuse 2. Now let's go very quick to check for power up fuse 2. We're gonna power there and no power there. Okay, so that means this fuse has no power. Okay, let's go check fuse 11. No power and no power. So that suggests we have an issue with the relay, not this wire, not the fuses, it's the relay. So which relay is this? That's going to be K2. And as you can see, these both show open. So that means both of them are going to close when we energize this circuit right here. So we're going to go check pin number 5. What do we want to see there? We want to see a good ground coming from the computer or voltage coming from the other side. Let's see what we have first, because even if we have ground here, doesn't if we have ground here and good power here, this should be on. Okay, but we don't have that. So let's go to K5. It's gonna be the control. It's gonna be brown or dark wire. No, it's not K5. That's K2. So I'm guessing this is my control wire. What do we have in there? We have high voltage, right? I mean, we have 5, 10, 12 volts. Right there, it's 5 volts per division. So that's 5, 10, 12. Well, let me just turn this off because it's distracting me. Okay, there you go. So 5, 10, 12. What does that mean? I mean, so that means we don't have the command from the PCM to turn the relay on. At least we don't get it at the relay. We're gonna go at the PCM itself, okay? For that, we're gonna have to hook up a breakout box. And we're gonna turn the ignition off like we do all the time. We're gonna connect our breakout box, okay? And since we have the breakout box connected, we're gonna go to pin, let me see, what was it? Pin number 8. Pin number 8. What do we want to see there? We want to see a good ground. Okay, so we're cranking. Actually, with just ignition on, we should see a good ground. Okay, now when we turn it off, we see a ground here. I mean, we see low voltage, but that's because we're losing the power that it's feeding the relay. Like I explained to you earlier, the voltage that we can read, this voltage that we can read here, this, it's the voltage going through the relay, okay? So we got voltage here, and it goes through the relay, and we're reading that voltage all the way down to pin number 8, okay? So the computer is not grounding that wire. Do we have a bad computer? We don't know. Uh, let's just um, let's just check our computer. Okay. What do we want to check on our computer? Pin 26. As you can see, it's fuse 6 and it's connected to power. 26. 3 and 37s are grounds. Okay. So let's start by checking pin 26. We have good voltage. Let's crank it. Yeah, it stays. Why am I cranking? Just to make sure that it's a good loaded test. 37. What do we have on 37? We're supposed to have what? Good ground, right? So, and what do we have? This is my zero line right here. So it's showing me right now like 5 volts on 37, which is this right here. Okay, so let's go to 3. Keep an eye on this 37 because that 5 volts on a ground, it's no good. Let's go to 3. Okay, and this test, I want you to pay attention to this. This test is good to prove something. It's good to prove that this is a good ground. Okay, why can we say that it's a good ground? Because if we're reading ground on pin number 3 and we're reading 5 volts on pin number 37, that means we have an issue with this wire. Okay, so on this simulator, it allows you to replace wires. So we're gonna click on it, and I don't know if you can hear that, but that thing just came back alive. We replaced the wire, and now we have what? Good ground. Okay, and I want to bet that this thing is gonna crank and it's gonna start. There you go. We don't want to blow the engine, right? Okay, so as you can see, that's what it takes to troubleshoot a system. This is not something that I knew that I was going to be dealing with, but that's how you troubleshoot electrical systems. Okay, so if okay, let me see. Let me take a minute to read this question. We have a question here. It says, if the cluster is working but RPM and speed always stay at 0, also VD2 scanner fails to connect every time. I cannot read it. I cannot read the rest. Okay, right there. If the cluster is working but RPM and speed always stayed at 0, also OBD2 scanner fails to connect every time. Is that necessarily a problem with ECM communication? Not necessarily, but it could be. It could be that you have an issue with the. It could be that you have an issue with the instrument cluster itself. But let's see. If you, my friend, if you're still there and you want to share the year, make, and model of the vehicle that you're working with, I'll be happy to take a look at it and try to troubleshoot what it is. I mean, we can spend some time on that. So this thing runs and we're done with it. So if you guys are going to be playing with this simulator, like I said earlier, I mean, it's free. You can go to that page right there, and we're gonna turn the engine off, and we're gonna put everything away because this is something that you gotta do here. You gotta put all the tools away, and let me see, breakout box. We remove the breakout box. We gotta plug in the computer again. we're gonna we're going to we're gonna put away our oscilloscope, not my diagnosis system, because I still want to I want to read codes. That's something that you want to do every time. Um, we go to fault codes, no ECM, clear fault codes anyways, and that should be it. Okay, so let's put away my multimeter, my instrument panel, my diagnostic system, and you gotta feel that work order. Diagnosis and work performed. Um, so we found a bad ground at pin, I think it was 37, right? On the ECM, okay? Replaced, replaced the bad wire and vehicle runs good now. Okay, that's something that we gotta do every time. I think we resolved the issue. We verified the repairs because the engine runs and diagnose and work perform. Okay, return the vehicle to the customer. This is one of the rare cases when it says that I completed everything. So let's return. Okay, let's return the car to the customer. Let's go. You know what? Since we are okay, C6 Corvette. I have issues saying P0. And Ace from Ace Auto Services, 2016. Okay, yeah, let's do this one. Why not? Let's do this one. Oh, let's change that. It's a one 2016 Corvette. I really like working with General Motor vehicles. 2016 Corvette, right there. And excuse my ignorance, my man, but is the C7 supercharged? I have no idea. So I'm gonna go with the natural aspirated. I don't know if it's supercharged. It should be the same. The supercharged should not have anything to do with the cooling fan. P0480 cooling fan. There is something before we go into the wiring diagrams. There is something that I want you to know about DTCs, and that's something that you want to do every time that you don't know or you don't understand what you're dealing with. Okay, you go to the vehicle and then you go right here. You read uh, under what conditions that DTC sets. Okay, for this one, it's a P0480. So we're just gonna find it right here, 480 P0480, and you want to read this right here. You want to read the description. You want to see the circuit system description, the theory of operation. I'm not going to read the whole thing, but if you don't understand something, if you don't understand what DTC you're dealing with, come over here, read all this, and you will figure it out. I mean, once you read how it works, you'll be able to troubleshoot. Okay, that's a little tip for you. This is gonna save you a lot of time many times. This along with the theory of operation of the component that you're testing. Let's go back to the wiring diagrams. Wiring diagrams. And this thing we can it's a student it's a student model. Okay. Well, hopefully it's the same. I mean, okay, because okay, so P0 cooling fan relay 1. Okay, P0480. Let's go see cooling fans. Where are they? Heating radiator cooling fan right here. Okay. Okay. Right. Charge air and charge air. I think this is gonna be charge air cooler. That's gonna be for the blower. That's if you have some kind of turbo supercharge. Anyways, so how does this one work? This one's gonna relay. Okay. It's got no relay, so cooling fan motor. Okay, so it's got no relay. So how does this work if we have no relay? That's actually a little bit easier to troubleshoot if you want to call it that way. Um, it's less wires. I mean, a relay, it'll be just like this. This one works with the relay. If this was your cooling fan and you have this relay, you'll be looking for control, high control, low control, and then your your load. You should have good input and good output. Okay, but this one doesn't have a relay, and this and on this. Okay. Okay, so on this one, what are we looking for? So it's very simple. This one works with something that we call a PWM signal, okay, pulse width modulated signal. Basically, what it does is that you have a component that is energized all the time or with ignition on. This one's all the time, hot at all times. And then you have a good ground. Okay, so this is there all the time. As long as you have a good battery, this should read good voltage over here. If you're using a power probe connected to your battery, this thing should indicate battery voltage, and your power probe should beep and it show you like the red light. Okay, also for the ground. Okay, it'll beep on the low tone and also show you a green light. Okay, that's a good ground. Now what kind of code are we getting? We getting a low voltage code. Okay, so the low voltage code is going to be generated because this controller wants to see something here, and what it sees is lower than what it wants to see. What am I talking about? So this controller right here, either it's shorted to ground, or you are missing this feed right here, or your cooling fan motor is defective. Why do I say it that way? Because if we cut the wire, let's say that we cut this wire or we disconnect the cooling fan motor, we have a bias voltage on this wire, okay, that the computer knows about. And once the computer sees that we have the bias voltage, that means a few things. One, this wire is compromised. Someone cut the wire, so somehow it got cut. A rodent, something cut the wire. Someone disconnected the cooling fan motor. This is broken in here, or your engine control module is defective. Something broken inside the PCM itself. Why is it that I'm telling you that that's not the case? I don't think that's the case because you have a low voltage code. Okay, so what would I want to check on this vehicle? I want to go in here, look for P number one, and make sure that with the engine running, okay, and high temperature, like a temperature where it'll call for this thing to run. Um, you want to see good voltage here. Either that, or you are commanding this PCM to turn it on. You want a good load um, test. Load test. I'm talking about you are monitoring what you are commanding. You are making this thing work. That's the only valid test that you want to do, unless you have a way to load test this wire. What am I talking about when I said load testing? Load testing, that means that you are gonna try to pull current through the wire. You're not just going to be reading the voltage. You want to make sure that this wire is it's working. It's the electrons are flowing through it. So how do you do that? One, it's commanding this thing on, and another one you could just hook up a live bulb here and connect the other end to ground. Like you could disconnect these two and put a light bulb, a good headlight bulb, something that is going to pull 3, 4, 5 amps, because that's what this guy's going to pull. And if it lights up okay and it stays high, that means this wire is good. Okay, but um, you don't run into that many. pretty often. So those are some rare cases that we get. Okay, so check for your fuse. Make sure you have a good fuse right here. Make sure you have good voltage. If we're reading a a low voltage code, that means we don't have voltage here, or we have a short to ground over here. So number one is going to be to check for voltage here. Uh, nonetheless, I mean, you want to check for ground, good ground here, good voltage here, and then if you had a scope, an oscilloscope, you can hook it up here and see what it does when you disconnect it. Okay, these should show you some kind of voltage. That voltage you might be able to even read it with the power prof or a multimeter. Okay, so you want to see what kind of voltage you have here with this thing disconnected. Okay, you want to see something here with this thing disconnected, otherwise you might have a short to ground on this wire. Okay, mine doesn't have a short to ground. I have checked power and ground, they're good, but I haven't done a done a load test. Okay, you haven't done a load test. Mm, so if your voltage is good and your ground is good, disconnect it. If you disconnect it and you get an open circuit code here, if your code changes to signal control high voltage or open circuit, if it changes, most likely you're dealing with a defective cooling fan motor. Okay, if it doesn't change and you read this wire with a multimeter and it shows 0 volts, there's a good chance that this wire is grounded, shorted to ground, or your PCM failed. Okay, um, at that point, let me tell you, I mean, this is something that we do at the shop whenever we can. We disconnect this plug and we depin it. Okay, uh, to make sure that we interrupt the short if we have a short on this wire. You can depin it and see if it changes to a different code, and especially an open circuit code. If you disconnected this one was low or shorted to ground, and then you disconnect this wire from the PCM and the code changes, that means this wire was grounded. Another thing that you can do, you can disconnect here and measure this wire to ground. Okay, you're gonna use a multimeter and you're gonna hook up one end to your chassis ground, your battery ground, and the other end over here, and you want to measure for resistance. Okay, you want to have very 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 high resistance. You want to get into the millions. Okay, your multimeter, if you're using a digital multimeter, on the highest scale, you should see OL, okay? O dot L on the highest scale, okay? You want an open circuit here. If you see very low resistance, let's say that you're measuring resistance, this disconnected, one pin to the ground, one pin of your multimeter, and the other pin here, and you can read like, let's say 200 ohms, that wire is it's shorted. Okay, shorted to ground. Especially if you can read like 2 or 3 ohms, I mean, that's very shorted to ground. um it'll be good if you can send me, you know what, if you go to my website, at californiasafetysystems.com, you can find it, you can find a link on my channel. If you go to my website, there is an email address there. Send me an email and I'll try to help you out to troubleshoot this thing. Okay, but those are the things that you can do for now. Now, let me tell you, if you depin this computer, you pull this wire out, right? You pull this wire out, and this thing still shows you a low voltage code, you very likely have a defective computer, but you don't call a defective computer unless you check all voltage and grounds on this computer. Okay, because it could be that the voltage, the circuit that gets energized to do circuitry testing, circuitry integrity. It could be the fuse is missing, okay, and it could be that you have a circuit that is being affected and the rest of the engine works. I mean, when you deal with with automotive, you see a lot of weird stuff, man. But hopefully this helped you, okay. If you're not able to figure it out, I mean, like I said, I mean, try to contact me on my website. Go to California Safety Systems, and there's an email there. You can reach me to there. Okay, if anyone else has another question, let's see if the let's go back to the first one that we had over there. Uh, if the cluster is working, but RPM and speed always stay at zero, also BD2 scanner fails to connect every time. Is that necessarily a problem with ECM communication? Okay, all right. So yeah, you're very welcome, my man. Ace Auto Services, you're very welcome. Where did where's this other guy? Monir 98, 99. So for the guy that asked about the OBD2 scanner and communication, I mean, if you could tell me what year make and model it was, I'll try to help you out a little bit more. Let's continue. You know what? I mean, now that I don't have anything else to do, but since we're having fun here, let's continue with level two of the simulator. Okay, whoever wants to stay and follow up, let's see what we have today. Welcome to level two. The engine runs irregularly. Okay, let's see what it does. So, instrument panel, oscilloscope, diagnosis system, breakout box, wiring diagram. Okay, let's crank it. All right, seems to be that we have a misfire. Okay, so how do we tackle this? How do we tackle this misfire? Uh, uh, Different ways. We can do. Let's say that we don't have a diagnostic system at the moment. Let's try to see if disconnecting components will help us identify. It looks like a misfire. Okay, it sounds like a misfire. Let's confirm. Let's disconnect injector one. No change. Okay, let's do it again. No change. Right. Let's do this one. Big change. Right. Okay. This one. Big change. Big change. Okay. So let's say that we don't have a uh, a diagnostic system for now. Okay, but we have our oscilloscope. Okay. So let's turn it on. Let's turn it on and hook it up to ground like that. We don't have a wiring diagram for the moment. Okay, let's just tackle this primitive way. So what do we have in here? Remember, common wire. Most of the times you're gonna have power. Let's go check. Right there. Let's see, 1 volt. So 5 volts per division. Okay, voltage, right? We have 5, 10, almost 15. Okay, and we should have the same on all of them. Okay, good power, good power, good power. Now let's go check the one that we have an issue with. Yeah, no power, right? No power, but good power here. Okay, do we have an issue with the fuse? No. Do we have an issue with the actual injector? We don't know yet. Okay, we most likely we might not. Well, you might have you if this car gets to your shop, you might have an injector, a fuse, a wire, a connector, and a PCM that is damaged because that's usually what we get at the shop. I mean, cars that have a bunch of different problems when the problem was just one. Why am I saying that we don't have a problem with the fuse? We saw that the other wires, all of them had good power, right? We most likely we're probably dealing with a bad wire, okay, to begin with. What checks are we gonna do? Well, we don't need to do many checks, right? Um, we don't need to do many checks. Why? Because we don't have power here, but we have it here. Okay, both of them, both of them run out of the same circuit, out of the same fuse. So we most likely have. I'm gonna do this. I'm just gonna replace this wire and see what it does. That's gonna be for injector one. Let's see. There you go. That's something you want to see. Okay. And let's check the other wire. That's gonna be my control, right? Let me bring this down a little bit so we can have a better view of that injector pattern. Okay, let's talk about injector patterns just for a second. Um, First, we want to see some repetition, okay? And then I'm gonna explain to you what we have right here. You see this line right here that has 0, 5, 10, 14 volts. This line right here, that's the voltage going in on the wire, right? Through the winding, out of the injector, all the way in to the PCM. Right now, we're not checking at the PCM, but we're checking at the injector, okay? So, you know what? Let me check it at the PCM, just so I can show you what I meant. That's gonna be pin number 11. There you go. Same pattern, right? Okay, now that's what I was talking about. Voltage going in through the injector, out of the injector, through the wire, all the way back to the PCM. We are reading that voltage all the time, except when the computer pulses the circuit down. So when the computer pulses the circuit down, since we have voltage and then the computer pulses to ground, on that particular moment, we have high and low, voltage and ground. For that instant, those 3, 4, 5, 6 milliseconds, that's when the injector opens up, and if there is good field pressure, it'll inject, right? That's what we call injection. So how do we troubleshoot an injector? Okay, well, number one, with just the ignition on, we should have good voltage here. Sorry about that. So we should have good voltage. Where does this voltage come from? I already told you. This from this splice through this wire through the injector, and we're reading all the way over here. Right now the injector is closed. Okay, why? Because the computer is not pulsing it. Once it pulses the injector during that pulse, it drops that circuit down, and the voltage drops across the component, and the injector fires. Okay, so this engine is running. All right, as you can see, as you can see, the injection responds to the acceleration. Okay, so we're gonna turn this off, and we're gonna what are we gonna say here? That we replaced a defective control wire or injector one, I think. So failure resolved, yes. Verify repairs, yes. Diagnosis and work performed. Let's disconnect my breakout box because we wanna read turn the ignition on. All four codes. Yeah, we had a bunch of codes. Hmm. Hopefully that was it. We disconnected some injectors and they didn't have anything to do with this. Camshaft position sensor circuit. Okay, clear fault codes. All right, no more fault codes. All right, let's clear fault codes. All fault codes again. Nothing there. Okay, turn the ignition off. Return. Shit. Instrument panel, oscilloscope, breakout box, and work order. Okay, so that was it. Let's see. Let's complete the last of the challenges today. There is an unknown problem. Find it and solve it. We didn't finish this? I thought I did. Shoot. New game. Damn. I had to start from the beginning again. Who wants to stay? Whoever wants to stay, let's do another one from the beginning. Oscilloscope, breakup box, wiring diagram. If what days you stream? You know what? I just started doing this. Uh, I did one like 6 months ago, and I did another one yesterday. But if you guys want to meet here tomorrow, I'll be here tomorrow at 8 p.m. Pacific time. Okay. Uh, we talk about whatever you guys want to talk about. Let's do let's do this one. What does it say? It says the engine does not run. Okay. There is something that I like, and that's to deal with engines that don't run. All right. Not even if you feed it. Eh, never mind. Okay. So engine does not run, but if I mean it starts and then it doesn't run. You want to do this today or you want to leave it for tomorrow? Let's give it a shot a little bit. See if we can make this thing run. Okay. It sounds honestly like fuel related, but let's see. Identify vehicle. Mm-hmm. Okay. Cylinder one, two, three, and four. Misfire detected. Okay. Math, throttle position correlation, mass or volume airflow circuit, range performance. Okay. Uh, at what point do you guys clear codes? You want to clear codes here? You don't clear codes unless you know what you're doing. Let me tell you that. Okay. Otherwise, don't clear codes. Um, Sometimes we get cars at the shop that have that have been that have been wrecked and they've been at a body shop, but two or three other mechanic shops, they come with 30, 40, 50 different codes. First thing I do, I delete codes. If you have a customer that comes in and it's got a check engine light and they have a problem and you can diagnose, I don't delete codes at that point. Okay. uh, in the future I'll explain why. Okay, so let's go systems. Engine management. Let's see what kind of data we get out of the airflow, out of the math and TPS throttle valve, throttle actuator, internal duty cycle, control throttle valve, ECM out, control throttle valve, control module in. Do we get a TPS? TPS, pedal position. Not now. Let's see this. Okay. And it's just display selection. Oh man, something that I hate is okay. That right there. We're gonna crank this. Oh shoot. And let's just watch for my airflow. Okay, let's see what we have there. 6.4 grams per second. It's gonna be an issue here. Okay, for starters, if this was a regular running engine with a four cylinder and I'm cranking and I can see 6.4 grams per second, I want to say that that's too high, but that's just cranking, right? That'll be, in my opinion, it'll be a little bit high for a four-cylinder engine. That is probably like something close to from 1.8 to 2.0, 2.2. Um, so it'll be kind of high, right? But I don't really think the problem is going to be there. Throttle actuator, internal duty cycle, and okay, this is one that I'm gonna have to read and probably continue tomorrow. How about that? Always watch your videos. They're awesome. Dude, thank you very much. Okay. So this one I'm gonna leave for tomorrow, okay? Just because I was supposed to do like 30 minutes and it's been an hour and 10 minutes. So how about we see each other tomorrow here uh at 8 p.m. Pacific time, okay? It's 10 p.m. Pacific time right now. Thank you very much for watching. And tomorrow, if you have anything specific to talk about electrical, I do a lot of electrical, and this channel I want to dedicate to electrical systems. You have any questions about electrical? Think about them. We'll see you here tomorrow. Thanks for watching.